So in this video we will deal two important pointers, that is non-cyclic ETS or photophosphorylation and cyclic. First we will start with non-cyclic. Here PS1, PS2 and PS1 both are required. This takes place in the grana or in the, I can say, oppressed region. So here I am drawing a scale 0, 200, 400, 600, minus 200, minus 400, minus 600. So this is the scale which shows the reduction potential. So first, here it is PS2. Here I am making. So light falls on PS2. Light falls on PS2. Here it is the lumen of the thylakoid. So here we have water splitting complex. Water splitting complex. So what happens? Here 4 electrons move to pH, that is phaeophytin. Then this requires energy because it is moving from high to low. General transport is from low to high. So here it is upgradient, upwards. So we need energy. So phaeophytin will give it to plastoquinone. 4 electrons again. But what about this? This becomes deficient in 4 electrons. So here water splitting complex by photolysis splits water. 2H2O splits into 4H plus 4 electrons plus O2. O2 goes out in the atmosphere. ATM I am writing goes out into the atmosphere, and 4 electrons are supplied to the PS2. 4 electrons are supplied to the PS2. After phaeophytin it goes to plastoquinone. From plastoquinone it will go to, which tell me, cytochrome B6F. From cytochrome B6F it will go to plastocyanin. From plastocyanin it will go to PS1. Again light falls on PS1. Again it is moving against the gradient. FES protein. It gives this electron to FES protein. Then this gives to ferrodoxin. This part of the board is visible. Ferrodoxin gives to FNR, which is ferrodoxin NADP reductase. So now in the stroma what happens? NADP gives rise to 2 NADP H plus 2H plus. You can see 2 NADP H is formed in the stroma. So let's revise the cycle again. So non-cyclic ETS, so photophosphorylation, PS2, PS1 in the grana, oppressed region. This I have drawn a scale of measuring the reduction potential. So PS2 gets light, 4 electrons are removed from it. pH is phaeophytin. From phaeophytin here it becomes deficient in 4 electrons, so water splitting complex breaks water. So 4 electrons are restored in PS2. Then pheophytene give 4 electron to plastoquinone. Plastoquinone give its electron to cytochrome B6F. Cytochrome B6F gives it to plastocyanin. Plastocyanin gives it to PS1. PS1 light falls on PS1 again. It excites against the gradient. FES protein gives it to ferredoxin. Ferredoxin gives it to FNR, which is ferredoxin NADP, reducing reductase. In stroma, NADP is converted into 2 NADP H plus 2 H plus. So in stroma we have this. This is the thylakoid membrane of the thylakoid, and water splitting complex is in the lumen. Here. So this was non-cyclic photophosphorylation or ETS. Now let's see cyclic ETS, which is different from it. Copy down this, then I will move it. So I'm rubbing the board. Cyclic ETS or cyclic photophosphorylation. It plays a role. Only PS1 plays a role in it. Only PS1. Unoppressed region. Unoppressed region. Very important. Unoppressed region. That is the free region. Stromal lamella is the site. What is the site? Stromal lamella. So we have seen that in non-cyclic photophosphorylation, NADP and ATP both are synthesized. So in this we will find out that only ATP is synthesized and no NADP. No NADP is synthesized. Let's start with PS1. PS1 is here. Light falls on PS1. Give us to FES or FRS, you can call. FRS gives it to ferredoxin. Ferredoxin gives it to plastoquinone. Plastoquinone gives it to cytochrome B6F. Then it gives to plastocyanin. And plastocyanin again returns the electrons to the PS1. There, in non-cyclic photophosphorylation, we saw that the water splitting complex is required to restore electrons, but here no external electron supply is required. This is a cycle which you can see. PS1 to FRS, FRS to ferredoxin, ferredoxin to plastoquinone, plastoquinone to cytochrome B6F, cytochrome B6F to PC, which is plastocyanin, plastocyanin back to PS1. So only ATP synthesis here, only ATP synthesis. So you may ask a question, where ATP synthesis takes place. So in this region there is the ATP synthesis. In this region the ATP synthesis is taken place. So now let's differentiate between cyclic ETS and non-cyclic ETS to get a clear idea about it. Get a clear idea. You only tell me the points for it. Separating non-cyclic here and cyclic here. So in non-cyclic you can see both PS1 and PS2, but in cyclic only one PS1. Site, tell me the site. Grana. Here stromal lamella. Stromal lamellae. Here oppressed region. here unoppressed region, here external source of electrons, external source of electrons, here no such source, here both are formed, NADPH plus ATP, here only ATP. These are the differences which you have to remember. So copy down the differences. So in the next class we are going to deal with important topics, that is C3 cycle, C4 cycle, photorespiration, CAM pathway. These are very important, so stay tuned for the next video because that will be more important. This is also important, but from the textbook you can understand this easier, and I am giving you a easier explanation than the textbook. Read the NCERT 1 or 2 times, and before coming to my class you should be perfect with this. So thank you for watching.